Okay, so first of all, I am aware that POH is in the high level, and I am also aware that heterogeneous, the syllabus also says, only homogeneous equilibria will be assessed. But this is, if I go up one, this is standard level, and it's right here in front of you. Okay, so we're doing it. I'm not going to think too much about it because it's not that hard anyway. And you've done equilibrium. So as we said before in equilibrium, if it's a heterogeneous equation, we don't count the liquids or the solids because they're too high in value and can't be quantitatively done sometimes. So when we do the KW, the equilibrium constant for water, for this equation here, we don't include the water. And for this one, because it's so commonly used, we give it its own special name. So we give this equilibrium constant a little w and call it the ionic product constant of water. And as you know, it's this already. And as you know from the previous video on hydrogen ion concentrations at pH 7 at standard ambient temperature and pressure, 25 degrees Celsius to 19.15, that it adds up to 14, the pH and the pH. And it's these two added together. Or times together, sorry. And so I don't know how well you know your logs, but when you do a pH conversion, the times turns into a plus. So I would just learn pH plus pOH gives 14, and I think this one here is in your data booklet. So just have a check because you're the one doing the data booklet, you're the one doing the test. Make sure you know which ones are in there and which ones are not, and which ones you have to learn. So another thing you need to know is that water is an endothermic process, and we're always assuming it's at standard ambient temperature and pressure. But what actually happens when you get warmer is more of this comes off and more of this comes off. So the hydrogen ion increases, the OH ion increases as well. And so you get pH values that are both lower than 7. And so what that actually means is you've got a situation, and because they're equal, so they're both going to increase by the same amount because the stoichiometric ratio. And because it's equal, you can still have a neutral solution that's higher, that has a higher or lower pH than 7, because it's neutral because the hydrogen ions and hydroxide ions are the same, but the pH is not 7 because those values are higher or lower than what they normally are. So that's a trick you need to be aware of. And in that case, it's not going to add up to 14 or 10 to the minus 14. Okay, it's going to be larger values than that if it's higher temperature, that is. Okay, so let's just do the calculations then with these new formulas. And so we've got the pH of sodium hydroxide. So we get the PO. We've only got the OH. We write out the formula, so that must be the OH concentration. So the POH is same as pH, but just a different thing. So it's 1.7, and we already know that the two added together is 14. So one minus the other, and the pH is 12. Okay, so high levels, is it high level, is it stand level? It doesn't matter, it's very easy, just do it.